So let's discuss the another MI another AI technology that is smart devices, that is smart words, smart phones, smart all sorts of smart home as well, smart car as well. So all are smarts actually. Now, the emergence of the Internet of Things (IoT) concept as a new direction of technological development raises new problems such as valid and timely identification of such devices, security vulnerabilities that can be exploited for malicious activities, and management of such devices. The communication of IoT devices generates traffic that has specific features and differences with respect to conventional devices. This research seeks to analyze the possibilities of applying such features for classifying devices, right, regardless of their functionality or purpose. Now, there are we are basically having, we are using rather smart watches, smart devices, smart cars also, it's out in the market. So in all those cases, artificial intelligence, all those technologies rather, AI is being used in in greater depth. It's being used heavily. Okay, now this kind of classification is necessary for dynamic and heterogeneous environments such as a smart home, where the number and types of devices grow daily. This research uses a total of 41 IoT devices. The logistic regression method enhanced by the concept of supervised machine learning was used for developing a classification model. Multi-class classification model was developed using 13 network traffic feature, and so on and so forth. The application of the IoT concept is in different economic sectors is becoming a key factor for business improvement. 92% of companies believe the IoT concept will be important for their business by the end of 2030. It will increase by 90 increase to 95% of all companies. Consequently, the companies consider security, privacy, cost, and regulatory issues. Pose the greatest challenges of implementing and applying the IoT concept. The largest representation of an application of the IoT concept, according to the number of IoT devices used until 2017, was in the area of smart building environments. Now, after 2017, the smart home concept is is an environment that brings together the largest number of IoT devices. More precise insight into the representation of the IoT devices by individual areas of application is provided by the research of the company. It can be seen that the smart home concept has the largest number of installed IoT devices. That's around 1 billion, 1000 million or 1 billion compared to other areas of application. The annual growth rate, prediction by 2021 is 19.6%, which makes the smart home concept, along with the industrial IoT concept CSG, 23.4%. The fastest growing area of application of the IoT concept. The classification of IoT devices is essential for several reasons. Successfully identifying IoT devices in particular scenario and environment can be vital in identifying illegitimate devices, unauthorized devices, unwanted devices as well, devices that do not behave as expected and have the potential to cause a security incident within the system. Yeah. So besides that, useful devices, classification and identification of new and hitherto unseen device can enable more efficient traffic management as well as network capacity required in the environments in which IoT devices exist. Okay. So that's the idea we can take, and we can have access to the smart devices, and basically, and also using smart devices can decrease the pollution as well. It's because, see, if we can use a smart car, so it can help us reduce the emission of CO2 and other greenhouse gases as well. So that's that this type of AI technology is can be a boost towards the reduction of pollution as well. So that's another technology. Now we will delve into another technology that's being driven by AI, that is you know speed recognition. Okay, we'll discuss virtual agents later on. So let's discuss the speech recognition. Now, electricity generation using the wind energy has been well recognized as environmentally friendly, socially beneficial, and economically competitive for many applicants. The power generating efficiency of a wind turbine can be significantly increased if the turbine's operation is controlled based on the information of wind and wind changes at the turbine location. However, due to unpredictable nature of wind speed from time to time and from location to location, it is difficult to estimate the utilization factor of wind farms. Therefore, accurate long-term and short-term forecasting of wind speed is vital for wind power generation systems efficiency. There are various strategies for wind speed predictions that can be classified into two categories. Number one, statistical methods that can be subdivided into numerical weather predictions, NWP, numerical weather prediction, NWP, and persistence. And number two, artificial intelligence techniques that have subdivisions such as neural network and fuzzy logic. Yeah, NN, that is neural network. Now, artificial intelligence methods for wind speed prediction background. Now this particular idea, that this in this case, AI can recognize the speed. AI basically recognize the speed focus as well. So this is very much useful in society, since by using this AI we can predict, we can basically we can predict the speed forecast, right? Okay, so the mathematical description of the wind pattern recognition prediction problem is to find and estimate Vk plus L of the wind vector, that is basically wind vector Vk. If we just talk about wind vector Vk, so this is we are getting deep, getting into the depth of speed recognition or speed forecasting by using AI a little bit. So let's get into some mathematical ideas as well. So if we just think about wind vector, if we take the wind vector Vk, and then we will estimate the Vk plus L, right, based on the previous m number of measurements. That is, we are measuring Vk or Vk plus 1, k plus k minus 1 rather, because we are going back, that is, we are going to the previous m number of measurements. So let's set the vectors, the wind vectors of Vk minus 1, Vk minus 2 up to Vk minus m plus 1. That is Vk minus whole of m minus 1. So right, so in order to have accurate wind speed prediction, L is chosen to be very small, and this is a short-term wind speed prediction. Application of time series prediction can be found in the areas of economic, inventory and production control, weather forecasting, and signal processing and control. A general method has been developed to generate fuzzy rules from some numerical input-output data pairs by by some research teams. They proposed a 5-step procedure for generating fuzzy rules from numerical data pairs, and as also they showed that how to use these fuzzy rules to obtain a mapping from input space to output space. Yeah. Meanwhile, they demonstrated that their new method can be used for time speed prediction and compared the results with those obtained using neural network predictor, NN predictor. Now, the developed method seems to be simpler and requires much less instruction time than a comparable neural network. So later on, another research team, they proved that the developed method, the previously developed method rather, is compatible with neural network and works quite well. Well, the main drawback of all proposed methods based on fuzzy logic in wind speed predictions is the large number of fuzzy rule base for accurate wind speed predictions. Having high number of wind speed measurements is necessary. However, by increasing the inputs for fuzzy logic block, the number of fuzzy rule based will be increased. Another research group proposed a time series prediction method using a fuzzy rule based system in order to solve the fuzzy logic drawback. In non-stationary system, they propose a method of building fuzzy rules, yeah, for prediction, which utilize the difference basically, of consecutive values in a time series, right? So a fuzzy model has been suggested for the prediction of wind speed and the produced rather electrical power at a wind park rather. Yeah, they trained their model using a genetic algorithm based learning scheme at various stations in and out around the wind park. Yeah, they improved the efficiency of short-term forecasting, which ranges from a few minutes rather, to several hours ahead. However, because of large number of wind speed measurements for fuzzy logic system, the dimension of fuzzy rule base is large and it consumes more computational time. Yeah, so in that case, if it takes more computational time, so it's a little bit problematic. Now artificial neural network comes into play. Now artificial neural network, ANN, is a promising technology in wind speed prediction. ANN has been widely utilized in various different fields including transient directions, pattern recognition, approximation and time series prediction. Two research workers, Lapidus and Ferber, proposed an ANN along with feed-forward and error-back propagation algorithm in wind speed prediction. Shong group developed an ANN-based methodology to perform a one-step-ahead prediction, which is found to be good, when the wind data does not oscillate violently. Now, Alex Ziadis et al. Also found that the ANN predictor is about 10% better than persistence model for one-step ahead prediction. In the past, many researchers try to choose the best structure for layer number, neuron number of different layers, and pre-processing and activation functions of ANN in order to get the most accurate forecasting. However, they lead to large and complicated network and long learning time process. Now several research workers propose a new strategy in wind speed prediction using the artificial neural network, ANN, or basically artificial intelligence more simply, as well as fuzzy logic. The proposed fuzzy logic not only provides significantly less rule base but also increased estimated wind speed accuracy when compared to traditional one. Meanwhile, the proposed ANN has less neuron numbers and less learning time process along with accurate wind speed prediction results. The experimental results demonstrate that the proposed method not only provides less computational time but also a better wind speed prediction performance. So let's explain a little bit about the proposed fuzzy logic and artificial neural network structure, that is ANN structure, in this type of prediction or speed forecasting by using ANN or more simply artificial intelligence. So coming into play now, the main structure of the proposed method basically shows that instead of directly applying the measured wind speeds in time series, the wind vector vk minus 1, that is previously measured m number of wind vectors, because we have measured m times, or rather we are guessing that it can be measured m times vk minus 1, vk minus 2, vk minus m plus 1, that is m times rather to fuzzy or ANN predictor and estimation of Vk plus L, Vk plus 2, Vk plus 1. Some static properties of the time series inputs such as standard deviation, average and slope have been calculated and have been used as inputs to fuzzy or neural predictor. First order linear regression between the date and time topology is applied to find the slope of corresponding input data. Indeed, authors found that these three statistic characteristics represent a perfect knowledge about all the properties of wind speed time series. By reducing the inputs to fuzzy interference system, there is a fuzzy interference system FIS, the fuzzy rule base will be reduced significantly. As one will see, all wind speed statistic process Now, the properties can be summarized in small rule base without sacrificing the estimated wind speed. Meanwhile, the proposed structure rather for neural network will reduce the ANN, that is artificial neural network size, by improving the prediction accuracy and will increase the learning process speed. In fact, the pre-processing block extras the desired features from the input data and makes the decision easier for ANN, which subsequently causes a reduced ANN size. In order to investigate the effectiveness of the proposed model, main benchmark tests have been carried out using the real wind data measured in Rostamabad in northern Iran for 2002 to 2005 period. These measured data have been averaged for every 30-minute interval for both fuzzy logic and neural network studies. The measured data for first 2 weeks of February, May, August, and November have been, averaged through 2002 to 2004. For each month, 672 samples are used as trained data for that month. Corresponding measurements for 2005 are used as test data. Now there are two types of data actually, test data and trained data. Now, trained data have been used for obtaining fuzzy logic rules and neural network learning processes in order to measure the performance of different methods to statistic properties such as root mean square error or MSE. RMSE is basically root mean square error. That's and that's basically 1 over n summation over I equals 1 to n caps n yi minus yip whole square, and the entire number will be square rooted. And the COD, coefficient of determination COD, will be used as well. That's 1 minus sigma y square by sigma y square, where sigma y is basically summation over I equals 1 to n yi minus ym whole square by n minus 1 by the whole entire quantity will be square rooted, and the sigma yx can be measured accordingly. The y part will be yip and the n minus 1 will be n minus 2. And n is the total number of data points and yi are the actual values of y. Yip are the predicted values for y, and yam is the mean of yi. Right? So that's the idea of speed recognition by artificial intelligence. More precisely, artificial neural network and fuzzy rules are being used rather in speed forecasting or speed recognition. So that's coming into play. In this case, AI is coming into play, and AI is really boosting this speed recognition or speed forecasting maybe a lot. And in this case, we are being helped by this AI tool. So I've discussed this part, rather this one. Now here speed recognition. Now I will discuss about some kind of augmented reality, another AI technology. Okay, so artificial intelligence is basically taking the market, is blowing the market, and we are being helped a lot by the artificial intelligence. Now, augmented reality is another kind of technology, AI technology, modern AI technologies. Now, what is augmented reality? Now, augmented reality is an augmented depiction of a reality formed by overlaying digital information on an image of objects being seen through a device or machine. Now artificial intelligence techniques have experienced unprecedented growth and are being applied in various industries. The combination of AR and AI is the next prominent direction in upcoming years, with many industries and academia recognizing the importance of their adoption. With advancement in the silicon industry that push the boundaries of Moore's law, processors will be less expensive, more efficient, and power optimized in the forthcoming years. Augmented reality is, one of such, AI technology that's bringing us closer to that. This is a tremendous support and necessity for an AR boom, and AR is basically augmented reality. So I will call augmented reality. I will abbreviate rather as AR. And with the help of AI, this is there's an excellent potential for smart industries to increase the production speed and workforce training, along with the improved manufacturing, error handling, assembly, and packaging. In this work, we provide a systematic review of recent advances, tools, techniques, and platforms of AI-empowered AR, that's augmented, reality, along with the challenges of using AI in AR applications. Right. So we are basically